Hey y'all, you've got Codeforces Round 898 coming at you today with a new camera. Shout out to my friend Lee who got me to get this camera. Pick two and swap, and most ones. Okay, so where's my terminal? Here, okay. Oh, CBA is also. Missed the 0-minute mark. It's okay, keep going. Ended its digits. Should I even think? I don't think so. I think always add to the smallest value. Anyway. Oh, I missed it again. It's not good. Got it. Okay, so we're just reading in the grid. What is it? X? Capital X. It's the min of 4 things. Five, 3, 6. It's kind of like that 5.5. greedy, yep. Okay, keep going. It's a coral made of end columns. This is I see. All right. AI fruits and heights HI. Wait, what? He collects all the fruits, but he can't collect more than K. Okay, I guess, sure. Oh, I didn't read H. It's F. Oh, this should be I. What am I doing? Wow. Okay. Still in the queue. Change the PC. Yeah, you basically take a B, slide it across an A, and C. Yeah, you have A runs that are separated by B runs. I need case input still. I need it for this problem too. This also needs case input. Okay, great. Got it. Judging is very behind. Okay, it's a tree. Wait. No. It's a functional graph? I see. Okay. I see. So we want functional graph. So who's trying to catch who? Marcel? No, Valerio is trying to catch Marcel. Oh, what? Oh, Marcel wants to catch Valerio. Valerio knows where Marcel's going to go. Oh, I didn't design this to work from. Is it just the cycle length is the most two, or they already start in a way where so then we how does he escape? He needs a cycle length of at least 3. He needs to be able to get this to the cycle without the other guy getting there. Yeah. So let's be sure it is. I'm gonna be super lazy. I'm so lazy. So it's release 3. The other thing is, so Valerio needs to go to what is it, depth? Valeri's distance, Marcel's distance. I see. Position. It's strictly less. What is this? Oh. That's really bad. Alright, we passed. Okay, so I have no reason to submit for the next 30 seconds or so. It's connected. It's over. Let's go. Wow. Okay, just by 2 seconds, by 1 second. That would put me at 72. Tied for third, I guess. Oh, there's a tie for first. Okay. Okay. Okay, time to eat. Back in a few. All right, so the contest is almost done. Still sitting third. Tied for third, actually, which is kind of funny. But by the way, I'm curious to hear what y'all think of this camera. Let me know what you think in the comments. But anyway, let's go through some problems. We can talk about these problems real quick and take a look. Well, first of all, let's look at the difficulties. So it looks like there was quite a bit of easy problems at the beginning, which is good. A, B, C, D, all very easy. In fact, every problem had more than 1,000 solves, which is kind of a lot. I actually think I was surprised at H having that many solves because it seems at least like slightly hard to me. But anyway, let's go through these. So problem A. You get A, B, and C in some order. You can do the following operation at most once. Pick a card and swap them. Can you make A, B, C? This is actually kind of funny because they just give you all the possible test cases in the sample. So you really could just... It's really just hard-coded for you. These are the only 4 ways to... This. These are the only 4 ways to output yes. Anyway, that's what my code does. I guess it could have been even easier to say... The only things you can't do are BCA, CAB. This would also work. In fact, we can just submit this for fun because it won't hurt our penalty at all. This is ICPC setup. So yeah, we're accepted. Didn't affect anything. But yeah, that's B, very simple. That's A. Problem B. You've got n digits, you want to multiply them all at the end, but you can increment one of them by 1. You want to make the max product. So I just didn't do any thinking, didn't feel like doing any thinking. I suspected that you just increase the smallest number, but I just coded it where I try all of them, because why not? But it is correct to increase the smallest number. The reason is that you add the product of all the remaining numbers, and that is maximized when you pick all of the biggest numbers you can. In which case you leave out the smallest number. So you could also implement it like this. This should be actually min. Just increment the min element, take the product, and we just output the product. And again, I'm going to submit because why not? What happened here? Oh, does this give me a... Does that not give me something I can increment? Oh, that's gonna be giving me a const. That's slightly annoying. Vector, begin, and end. These are const, right? Let's go this way. Yeah, this is a const. Why does it even let me compile this code then? That's surprising. Let's see. Like I can do a that's really silly. Okay, I'm not 100% sure why that fails like that. If you know, let me know in the comments. Let's submit this. Should be good, and we're good. Yep. All right. Problem C. Yeah, you're given a 10 by 10 grid. You just need to calculate all the points given this arrangement. Essentially what I did is you're just taking the min of the row score and the column score. The row score looks like 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. The way I set that up is actually essentially if you have a row of I, it's actually 5.5 minus absolute value of 4.5 minus I. The reason is 4.5 minus I is only 1/2 when you're either of these two, 4 or 5. It's 1.5 when you're 3 or 6, 2.5 when you're 2 or 7, and so on. So this is what you want. Unfortunately, this uses floats, which is not great, so I just doubled this, and then I divided it by 2. And that's what's going on here. And then I take the min score of the row and the column. And that's C. All right, D. Yeah, you take any k consecutive cells, you want to make them all white in one operation, and you want to find the min number of operations to remove all the black cells. So I just greedy. As soon as you find a black cell, you just start removing from there and you keep going right. What's funny is I actually don't need this. I mean, it doesn't hurt, but it doesn't matter. You can just feel free to continue the I loop as usual. Yeah, just iterate through, and then this looks kind of n-squared, but it's not because you can only you can only paint and arrange white once. You can never paint the same thing twice. So that's D. I don't know if I can submit now. I can try. Okay, it does work. Oh, right, because there's no system test phase. Did I? Why would that change the results? Doesn't make any sense to me. Oh, how did I? Oh, I said SI equals W. Well, then my code is wrong. Oh, my code was only right because wow, that is lucky. So I had a bug here where I set SI to W, but it didn't matter because I incremented by enough to go to the next one. So my code is actually still fine. That's very funny. Very lucky. Yeah, so this is fine. Wow. Yeah, I guess from that perspective, you could actually just do this. You don't need to overwrite anything. You just jump. And that would also work. This is basically what my code is doing. Right. Okay. That's pretty funny. Anyway, got lucky there. It's fine, no big deal. Problem E, an aquarium. And a bunch of details, we're gonna fill in some water. We wanna figure out what's the largest value of h we can select so we don't use more than x water. So what I did is I just binary search the answer. And then given an h, it's very easy to calculate how much water you're going to use. It's actually just, you just take h minus a, but you don't allow that to be negative. So I can do this, for example. Or I could do this. Yeah, so we just binary search on the answer, check if the answer works. If it is, or check if our value works. If it does, that's our new lower bound. If not, we have a new upper bound. Do this binary search, and we're good. You can also do this in a slightly better time complexity if you you can realize the order of the, what are these called? Corals, I guess. The order of these doesn't matter. This 3, 1, 2, 4, 6, 2, 5. It could just be 1, 2, 2, 3, 4, 5, 6. And then you can kind of, from that sort of order, you can just calculate relatively easily how much h you can get if you just assume that h is between one coral and the next coral. It just becomes a division problem. So then you're just bounded by the sort time. But this is totally fine. This is easier to code, so you might as well go for this to, you know, get more points, solve the problem faster. All right, problem F. So problem F, you just need to pick a subarray. There's a couple rules. You need this divisibility, and you need the sum of the a values to be at most k. And you want to pick the biggest array you can. So in my case, I just iterate the start of the subarray from the right all the way to the left. I guess I'm mirrored in this video, so from right to left. And then we know how far we can go with the divisibility rule. And then we can binary search on how far we can go with the subarray sum rule. And we use prefix sums to calculate the sums. You just subtract two prefix sums as usual, and you can get the subarray sum. And that will give us how far our right endpoint can be for our current left endpoint. Max, just take the max of that over every left endpoint, and that's our answer. So that's F. Problem G. Yes, okay. So problem G has two types of operations. AB changes to BC, or BA changes to CB. And we don't have any C's initially, we have A's and B's. We want to figure out how many times we can do an operation. So the way I thought of this was, it's like B is jumping over the A, and then turning it into a C, which means it can't jump back over the C in the other direction. So if you take any particular B, it can only jump in the same one direction for a while and then stop. It can never turn around. So we can think about, it's better to think about the input as runs of A's and B's. So I use my run length encoding, which basically will tell something like, you know, there's 3 A's and then 2 B's and then 4 A's, right, in the stream. It turns out that there's a couple conditions that allow us to get everything, as in all of the A's. That would be if either we start with the B, or we end with the B, or at any point we have a run of 2 or more B's. In those cases, we can always get all of the A's. You can, you know, try a couple of examples, convince yourself why that's true. But basically, the only case where we can't get all the A's is when we have a run of A's, a single B, a run of A's, a single B, and so on. And then finally we end with a run of A's. And in that case, since each B can only go in one direction, it can only fully finish one of the runs of A's on its 2 sides. And so, in other words, what we can do is we can get all of the runs of A's except for one. So for example, if we have A, B, B, this B can go this way to the left, or it can go this way to the right. Same thing for this B, it can go this way to the left, or it can go to the right. And we can actually pick any, we can actually pick any single run of A's to exclude. So because this is the smallest run of A's, we can exclude it by having this B go to the right and having these B's both go to the left. But if we ever have any more B's than this at any point, for example, B at the end, we can have all the B's go to the left, B at the beginning, we have all B's go to the right, again, cover all the A's. Or if we have any point where there's two B's or more, for example, here, we have this B go to the right, we have all these B's go to the left. So we can always cover all the A's as long as we have one or more extra compared to that. So I just check for if we have enough to do everything. Otherwise, we just want to know the sum of the A's, the A counts, and the min of the A counts. If we have enough, it's just all of the A's. Otherwise, it's we need to remove the min of the A counts. And then this max is just to make sure that, actually, I guess we don't need this max. It's just to make sure that if there are no A's, we don't print something negative. But if there are no A's, we should be in enough case anyway. So it wasn't necessary, but might as well be safe. Okay, that's G. Finally, problem H. So in problem H, we have a functional graph in this case, which is a graph with, it's not exactly a functional graph because it's not directed in this case, but it's a graph with exactly one cycle per component. So it looks like this. Each component has a cycle, and each node of the cycle has a tree hanging off of it. So in this case, this is a cycle of 3, and this node has a tree with one child on it. These are sort of trees with no additional nodes. In this case, this is cycle of length 2, and this node number 2 has a tree hanging off of it here, whereas node 5 is kind of its own tree. Okay, so it is the cycle of trees functional graph. It's also a single connected component right here. And so we want to know if, who is it? If Valerio can escape Marcel. Valerio also knows where Marcel is going to go. So first of all, if the cycle size, there's only going to be one cycle because it's one component. If the cycle size is 2 or less, then Marcel can always catch Valerio. Why is that? It's because, so first of all, if you have a tree and Marcel is above Valerio in the tree, as like closer to the root, is an ancestor of Valerio, or even just closer to the root, then Marcel can always catch Valerio. The way to do this is basically by moving toward Valerio, and Valerio has nowhere to escape because we'll end up getting stuck in a leaf of the tree. Otherwise, the way that Valerio can escape is by essentially getting to the cycle and just staying away from Marcel. But if the cycle length is only 2, then Marcel can go to the cycle, and then presumably Valerio is on the other tree or the other node of the cycle, and then Marcel can just go to that other node and then go down the tree. However, if it's 3 or more, then if Marcel can get to the cycle, he can just keep away from Valerio in the cycle. Because he knows where Valerio is going, he can always just avoid him within the cycle. So we just have to compute a couple things. One is, in order for Valerio to escape, we need the cycle to be at least length 3. And then the other thing we need is that Marcel cannot catch Valerio before he gets to the cycle. So we just need to calculate what is the distance for Marcel to get to the cycle, and what is the distance for Valerio to, sorry, what is the distance for, I'm mixing up which player is which. What is the distance for Valerio to get to the cycle? And what's the distance for Marcel to get to that same node in the cycle? So that's all we do. This is a bunch of like boilerplate code to compute these distances. I was very lazy, I just used a lot of free written code. But essentially, our conditions are cycle length of at least 3, and then we need that to escape, and we also need Valerio distance is less than the Marcel distance to the cycle plus the distance of the 2 nodes within the cycle. And that cycle node distance is a min of 2 options. We can go one way or the other way. And that's it, yeah. All right, so that's it for this contest. I'm gonna close it out here. But again, yeah, shout out to my friend Lee for the camera. Yeah, let me know what you guys think. If you want to catch my future videos, feel free to subscribe to the channel, and I'll see you again.